In each of the following questions, 3 statements are followed by 2 conclusions. You have to identify which of the following conclusions does not follow. Which of the following conclusion does not follow, right? It's not about what follows, it is about what does not follow. All right. So let's look at it. What do? The process remains the same. Draw the basic diagram for the given statements. Now the statements are some T are not Q, some Q are not M, all M are J. So draw the basic diagram. Some T are not Q. How do you draw this? Some T are not Q. The basic diagram for some A's are not B's is as follows, right? Some T are not Q. But one point to be noted is we are referring to the section which shows only T. Some T are not Q. Which T are not Q? These outside T are not Q. Some T are not Q. These T's which are outside are not Q, right? The point that we are trying to make is for some A's are B's. How do you draw some A's are B's? The basic way of drawing some A's are B's. Some A's are B's. The diagram is this, A and B. Similarly, some A's are not B's. Some A's are not B's. What's the diagram? The same one. But the difference is when you talk about some A's are B's, you are referring to this region, shaded region. When you're talking about some A's are not B's, we are referring to this region, the external region here, right? So it is very important that though the diagram is same, you should be very clear as to what are you referring to. Some T's are not Q, so I'm referring to these T's. Then some Q's are not M, some Q are not M. You draw M this way. Some Q are not M. So these Q's are not M, the outside Q's, right? Outside Q's are not M. I mean, again, I have to use a different shading just for the sake of explanation, right? So some Q's are not M. Which Q's are not M? These Q's are not M, the ones where we have got vertical shading. And the last statement says all M are J, all the M are J, all the M are J. So that's the basic diagram, right? This is the basic diagram for the given question. Some T's are not Q, some Q are not M, all M are J. Now look at the conclusion. The first one, some Q are not J. Some Q are not J. Is it true? Some Q are not J. Well, if you look at the basic diagram, some Q are not J is true. I can say that these outside Q's are not J. Q and J definitely overlap here. This region shows overlapping between Q and J, but those Q's which are outside are not J. So some Q are not J is true with respect to the basic diagram. But can we say that the conclusion is true just because it has followed the basic diagram? No. The classical law in syllogisms, while you are solving questions from syllogisms, is that when a conclusion does not follow the basic diagram, it is false. But when a conclusion follows the basic diagram, it need not be true. You have to check the possible diagrams as well. So what is happening here? Some Q's are not J is followed in the basic diagram. It follows the basic diagram. So can I mark it as true? No. I have to check the possible diagrams. And if you have practiced enough on syllogisms, you would know that the first conclusion does not follow. Some Q are not J does not follow because it fails in one of the possible diagram. Which possible diagram? Let me show it to you. See, the statement says all M are J. The last statement, if you see, it says all M are J. So we have drawn J in this format in the basic diagram. But one way of drawing J is this. Can I draw J in this fashion? Yes, I can draw it. Nothing wrong in it. Are we violating the statement? No. The statement said all M are J. Here you see all the M are J. All the M are inside J. Or we can draw even larger J also. We can draw J in this fashion also. Are we violating the statement? No. The statement said all M are J. Yes, all the M are J. All M are J. Now the point is the moment I take any one of this, let's say J and J dash or J double dash or whatever whatever you call it, you find that the first conclusion fails. See, some Q are not J. Now tell me which Q is not J. In J dash and J double dash, you find that all the Q's are becoming J's. All the Q's are becoming J's. All the Q's are inside J. The moment all the Q's are inside J, can we say some Q's are not J? No. All the Q's are J. When all the Q's are J, how can you say some Q's are not J? Which means, though conclusion 1 satisfies the basic diagram, the purple J, it does not satisfy the green J. Hence, it is wrong. Are you able to follow? Conclusion 1 does not satisfy the possible diagram for this one. Some Q are not J. Some Q are not J. Some Q are not J is wrong. Now look at the second conclusion. Some Q can be M. Some Q can be M. So I'll just clear up this possible diagrams for J that we have drawn. Let's not get confused because those were considered only for the previous conclusion. Now let us look at the next conclusion. Next conclusion says some Q's can be M. Some Q's can be M. True or false? Some Q's can be M. True. Yes or no? Some Q's can be M is true, right? Let me go back to the original color. The conclusion says some Q's can be M. When you look at the basic diagram, yes, some Q's can be M, true. See, it is a possibility type. Remember, some Q can be M. Can be M, he says. Can be M. This is a possibility type. Right? The first one was a definite type of conclusion. Second one is a possibility type of conclusion. He says it is possible that some Q can be M. The word can means what? Some Q can be M. It is possible that some Q can be M. Yes. In the basic diagram, I can see that yes, some Q can be M. You look at this overlapping. Some Q can be M. So this one follows. Yes or no? Again, remember, why am I saying that this is a possibility here? Because if you look at it, the statement said some Q's are not M. Some Q's are not M can also be drawn in this way. Q's and M's. I can also draw some Q's are not M in this fashion. Are you getting it? Some Q's are not M. Q's here and M here. Yes, I can always choose some of these Q's and say these are not M. What we have drawn here is a basic way of drawing it. Some A's are not B's. This is a basic way of drawing it. But remember, some A's are not B's can also be drawn in this way. So if I draw it in this way, what happens? Some Q can be M becomes false. But here it is true. And since it is a possibility type, it should be true in only, it need not be true in all the cases. It can be true in only one of the cases. So yes, some Q can be M is true in this case. Hence it is correct. Are you able to follow? So the answer to this question will be what? Conclusion 1 does not follow. Conclusion 2 follows. What is he asking us to find out? You have to identify which of the following conclusion does not follow. Our answer should be conclusion 1. You're able to follow? Final answer to this should be conclusion 1. Conclusion 1. Why are you saying that answer should be conclusion 1? Because the question said find out or identify the conclusions which do not follow. 1 does not follow. 2 follows. 1 does not follow. So answer is conclusion 1. Conclusion 1 does not follow. Again, I am repeating, don't get confused. It's not that conclusion 1 follows. It says conclusion 1 does not follow. So a simple question from syllogism. 3 statements, 2 conclusions, but because there are, some A's are not these types of statements given to us, you have to be careful about drawing the diagram there. And again, more importantly, the directions are, not the usual ones, right? He's not asking us to find out what follows. He's asking us to find out what does not follow. All right.